Imagine a planet so impossible, so deeply wrong, that scientists had to triple-check their instruments just to believe it was real. A world where gravity, the force that holds oceans down, shapes planets, binds galaxies, seems to barely function at all. This planet behaves as if gravity simply doesn't exist. Its atmosphere rises instead of sinking. Clouds drift upward like smoke in reverse. Objects would fall so slowly you could walk alongside them. And yet this is not science fiction. This is a real exoplanet, detected by NASA and the James Webb Space Telescope, a world so bizarre that it instantly became one of the most puzzling discoveries in modern astronomy. When Webb captured its first measurements, the team expected to find a typical gas giant. Instead, they found a physical anomaly, so dramatic that some researchers thought the data was corrupted. The planet was enormous, nearly the size of Jupiter, but its mass? Shockingly tiny. So tiny that its gravitational pull appeared to be only a fraction of what physics predicts for a world that large. Simply put, this was a giant planet acting like a cosmic balloon. Its atmosphere extended tens of thousands of kilometers into space, so stretched and inflated that it looked like a translucent sphere of haze rather than a solid body. If you could scoop a handful of the planet's material, it would weigh less than the air in your room. In fact, its density is so low that if a cosmic ocean existed, the planet would float. This kind of world shouldn't exist. Not for long, not around an old star. And yet here it is, stable, luminous, drifting quietly through its orbit. The first question scientists asked was simple. How is this possible? How does a planet resist gravity so effectively? How does its atmosphere avoid collapsing inward? And why does this world look like it was stretched from within by some invisible force? Webb's instruments tried to uncover atmospheric chemistry, looking for water, methane, hydrogen, anything that could explain this strange structure. But what Webb found was even more mysterious. Nothing. A completely flat spectrum, as if the atmosphere were hiding behind a massive, uniform haze. And this haze was no ordinary haze. It had to be thicker, stranger, more impenetrable than anything ever observed in our solar system. Something about this world is concealing its true nature, and scientists are now racing to understand what that something is. To grasp how strange this planet really is, we need to look at how gravity normally works. The larger a planet becomes, the stronger its gravitational pull. Gravity compresses the atmosphere, tightens the interior, and increases density. But that is the opposite of what happened here. Instead of compressing, the planet expanded. Instead of tightening, it puffed outward. Instead of becoming denser with age, it became lighter, so light that its atmosphere floats like mist in sunlight. Scientists quickly ruled out basic explanations. The planet isn't hot enough for thermal expansion to cause such extreme inflation. It isn't young enough to still be swollen from formation. It isn't close enough to its star for tidal forces to pull it apart. And its composition doesn't match any known type of low-density world. That left one possibility. Something extremely unusual is happening inside the planet, or around it. Webb's flat spectrum hinted that a massive haze layer hides the deeper atmosphere. But such haze cannot form naturally without an extraordinary chemical process or energy source. Perhaps internal heat is pumping gas upward like a geyser, replenishing the atmosphere and keeping it inflated. Perhaps unseen geological activity, cryovolcanoes, internal convection, exotic chemical reactions, is constantly feeding material into the upper layers. But if so, where is the energy coming from? The star is too old, the orbit too stable, the temperature too low. One theory proposes an unseen companion planet tugging on this world, generating internal friction and heat. But so far, no gravitational anomalies have been detected. Another scenario? The planet formed in a distant icy region and migrated inward, keeping a core made of frozen volatiles that now evaporate endlessly, producing a planet-sized fog. But even this model fails to reproduce the scale we see. And so scientists arrived at an unsettling possibility. This planet may be part of a completely new class of objects, worlds shaped less by gravity and more by unusual internal or atmospheric physics that we have never observed before. Something is preventing this planet from collapsing. Something is keeping its atmosphere so inflated that it stretches beyond any known limit.
And as Webb continues studying the planet, the mystery deepens.
The deeper astronomers look, the stranger the planet becomes. Instead of finding clues that help narrow the mystery, every observation opens new questions. For example, the atmosphere behaves like it is only loosely attached to the planet. Winds move so slowly that even a feather would drift for hours before settling. Temperature gradients are too gentle to produce strong storms. The entire world seems to exist in a delicate balance of forces so weak that the slightest change should make the atmosphere collapse. Yet it doesn't. That stability is perhaps the biggest mystery of all. If the planet were truly as light as it seems, gravity should slowly compress it over billions of years. But this world remains swollen, like a balloon that never leaks. What keeps it inflated? Could it be evaporating from the inside out? Some models suggest that the planet is constantly losing gas to space, its atmosphere drifting upward in elegant ribbons. Webb detected hints of atmospheric escape, but not enough to match what we see visually. Could it be that the planet once had far more mass and has slowly shed it over time, leaving behind an empty shell of gas? Or is the planet not losing mass at all, but instead being fed from within by a massive reservoir of volatile ices sublimating in vast quantities? Another radical theory proposes the planet is partially hollow, not literally empty, but composed of exotic structures or ultra-low density materials formed under extreme conditions during its birth. A hollow structure would naturally resist gravitational compression, producing the strange behavior we observe. But that idea demands completely new physics of planetary formation. Still, something about this world doesn't match anything in our catalogs. Not super-Earth, not mini-Neptune, not gas giant, not brown dwarf. It sits in a category of its own. Even the star it orbits hints at something odd. Stars influence their planets profoundly, yet this star shows no signs of unusual activity. It is calm, mature, stable, and yet its planet behaves like a cosmic anomaly. Scientists expected this discovery to become clearer with time. Instead, each layer peeled away only reveals a deeper, more unsettling layer beneath. And the most dramatic revelations were yet to come.
NASA and ESA have now prioritized this planet as one of the most critical targets for future Webb observations. If the haze theory is correct, Webb may soon detect faint scattering patterns caused by exotic aerosols suspended in the upper atmosphere. These particles could be made of hydrocarbons, silicate dust, or even crystallized compounds never seen before. If atmospheric escape is extreme, Webb might map streams of hydrogen peeling off the planet like comet tails. If internal heating drives the inflation, infrared measurements may reveal glowing hotspots deep beneath the haze. But there is one possibility that excites scientists more than any other. What if this planet represents a stage in planetary evolution we have never witnessed before? A transitional world, frozen in a rare moment where internal forces push back against gravitational collapse. A planet where gravity hasn't failed, but is being outmatched by something far more powerful. If that's true, this planet might rewrite our models of how gas giants evolve. It may explain how some planets shrink, some inflate, and some become completely unstable. It could even provide clues to the strange early phases of planets in our own solar system, moments we can no longer see today. And there is an even larger implication. If one planet behaves this way, there may be others. Entire populations of gravity-defying worlds drifting across the galaxy, each hiding its structure behind colossal haze layers, each challenging our understanding of physics. This planet has stunned scientists not because it breaks the rules, but because it exposes how incomplete those rules still are. It proves that the universe isn't finished surprising us. It proves that nature still has secrets we haven't discovered. And it reminds us of something profound. Gravity may be universal, but its effects are anything but simple. This strange world is not just a puzzle, it is a hint that the cosmos is far more diverse, far more dynamic, and far more unpredictable than we've ever imagined. The universe is full of planets like this, waiting to be found, and the next one could be even stranger. This is only the beginning.